Touch it.
Where's my phone? My phone.
I throw it outside.
No, you're not.
Yeah.
No.
Yes, when you went to get it, I threw it. It's on the
Stephen!
floor.
You wouldn't let me in.
You wouldn't let
But
us in.
I opened the door.
That's bullying.
I opened the door.
Exactly.
No,
By
I
force.
opened the door. I'm the person who opened the door.
No.
Yeah.
Oh my goodness.
Well, but at least I
I'm so
opened the door
tired.
for you guys.
He saw the sign.
Did you take a picture?
Yeah. No, I didn't. I was about
Then
to. I was
no
on the
picture,
bus.
no belief. No picture, no believing.
It's in Walkinstown, opposite Cherry Tree.
I want a picture or I'm not believing this. Because I do not believe.
No, but I don't
Apparently,
think- I
there's
don't-
an advertisement for my website in Walkinstown.
What?
Yeah.
Yeah, it's next to Spar. It's right next to Spar on the way back home. I saw
Now,
it.
is it
But
my...
I don't think it's yours.
It just says mass crimes.
Yeah.
But that doesn't count.
You can sue with them.
No, I can't, because mass crimes is a generic term in Ireland. It means mass health. So I'm afraid this is not my website.
I don't.
Google Maps Street View.
I'm on Google Maps.
No.
This is true.
What
Street
the-
View?
Yeah.
I suppose.
I don't think it'll be up to date.
No, the caravan, the one from our homestay is on Street View.
No, it's not.
Yeah,
Yeah,
but-
the caravan, but it's been there for years.
Ay caramba. Right, can you take out Moodle? Because we're going to start our revision now.
Cry, cry, cry. Lock the door on the class up again.
You're not the king.
I'm not what?
You're not the king.
Almost. I'm the class rep.
He's the queen.
Please say have the power.
Burn!
What do they call Andrew, what's Shako called in all kingdoms?
The jester.
The jester. Yeah, the jester.
Clown.
Yeah, Google that.
Clown? Oh, she can't use a phone, lol! Can you open Moodle, please? Okay, now seriously, where is her phone actually?
Yeah, seriously.
Let me be quiet. Seriously, Faisal, where is her
I
phone?
throw it outside.
It should be outside?
Unless someone else picks it.
Does anyone have Fuan's phone?
Yeah. Salam.
Huh? Oh,
Let's give it back to her.
Yeah. It has a lot of information inside.
Important.
Yeah, let's have
Yeah.
a look.
Okay, let's ask Mr. Steven. Mr. Steven, if you would buy this phone,
Will I buy this phone?
how much would you buy it for?
Let's have a look at gallery here.
It's an S3,
You got interesting pictures?
Yes.
maybe private pictures, don't open.
Should I open?
You can't.
I can't. Oh, let's see if I
Yeah.
can. Oh.
You can open the camera and
Wait,
take
wait,
pictures
wait,
of
wait, wait,
yourself.
wait.
Her birthday.
1990 maybe.
No, it's
No?
0904.
But that's not the number. The security is not the number.
Oh, it's a pattern. Yeah.
Oh, draw a square.
Yeah. What? You can't. I'm
The
sorry,
other
you
direction.
can't. Because
It's
the
not
most
it's maybe
difficult.
as
You think your pattern is more difficult than mine?
What is your?
I'll show it to you once, and I'll
Yeah.
give you the phone. And if you open it, you have my phone. I swear to God, if she opens it. I'll be so disappointed with my...
You said you'd give her your phone, and that was recorded, I think. That you can.
Wrong.
You can only try once, I guess.
Wow.
Show it to me once. I'll do it.
You've seen it.
You can't.
I haven't focused on it.
Yeah,
Are you sure?
Me?
You've all seen it.
No.
Just keep on doing attempts until the phone gets locked. So she can't use it
Oh,
for
or
the
you
next
can have
30
your
minutes.
computer and. Programming genius. One out.
Oh wait, the Samsung.
Should I give you
The
video?
Yes. You have a key? I don't have a key. Do you have a key?
the USB? Yeah.
Okay, you can put on a key. Right, have you got Moodle open?
No, I'll do it directly to you.
Can you do it again?
Maybe.
Oh yeah, I'll show you what I was doing,
Wait.
but I didn't finish it yet.
Wait till you Google pictures and then you take the...
No.
Unless I buy it.
Right, let's start with the exemplar exam. Can you open up the exemplar exam, please, on Moodle?
The monitor is in his body, and then the background is just a background. So.
What is this hair?
Please.
Oh, whose hair is that?
Yeah, who?
Oh, Font,
Absolutely
what
not
are you
me.
doing?
Absolutely not me.
Wait. Okay, let's see if Linux is compatible with whatever the heck that is.
Are you aware you have 10 names on
Dude, is the exemplar exam open?
Yes. Name repeat.
You can use my... I had...
Can I change it?
Wait, guys, can we focus? Do you have the exemplar open?
Yeah, that's...
DCIM camera.
Just give it a moment. Your phone is trying to keep up with my laptop.
Yeah, sure.
What is A1 about?
What's your wrong?
I think. Yeah, so
The only video probably.
This one looks like it.
312.
Yeah.
Wait.
The 31st of March,
Yep. Was it?
wasn't it? That's only a couple of days ago.
Wait. Just to be sure.
A Friday.
Don't want to expose myself.
Yes, please. Please. I don't want any compromising videos that will haunt me for the rest of my life.
31st of March, 289 megabytes.
Yeah, but because of rounding on
Yeah.
systems, it might look different.
Okay. That's a really good video, actually.
Ah, no, I don't want to hear myself. Right, sorry. A1, read it to me, Yusuf.
You missed this.
Oh, yeah, she did. She'll have to watch YouTube later.
What is that?
Watch YouTube later.
Ever.
We did
Best class ever.
experiment
Best class ever.
in the IT room.
Ah!
Using sound.
Wow.
The double slit.
But I didn't have...
Yeah, we know.
Wow.
It's
We
your
all
fault.
didn't have buses, but we all came.
In walking.
From walking stand.
Walking.
Why?
Oh my
Like,
goodness.
every time you can do it, why to do it when I not there?
Because you're very
Because we
noisy.
don't want you to
No,
be
that was the only day we had the ICT.
It was the only time we had the room with the two speakers in it. Thank you.
Ah.
Thank you. Right. Yusuf, please read the question. Goodness sake.
Uniform plank of wood of mass 5.5
Yeah.
kilograms is supported by two stands A and B as shown below. Determine the upwards force.
Perfect. Stop talking. Great. Now, I want A1 comes from the mechanics part of the course. You should be able to do A1. I will give you 5 minutes to do A1, then I'm doing it. Then we'll have a look at what A2 is. Get it on your phone.
What if I solved it already?
Did you really? Good man. What's that door? Where's Omar?
He's sick, so he goes to
He
the
came, but
doctor.
he
He
was
didn't go home, he went to the
Doctor.
doctor.
Okie dokie. Well, Faisal, all that's going to happen is after I do this exam, I'm just going to move to the next exam in the papers.
Okay, so
Have you finished all of this exam? I mean,
So the question that...
so you've done, yeah. So if you go to last year's exam version 1 in end of semester 2, but of course only do the questions that we've covered in semester 1.
Okay.
That's how I'm going to do the revision. Has anyone else got this done?
No. Where is that? Do we have class tomorrow?
I don't even know. I don't even know if we have class now with the way things are going. Are people doing this question, please? So why are you sitting beside me?
Too much music.
Yeah, exactly. Go sit beside someone else, Faisal or something.
Wow. No.
He can take the hit. He's the head of the class. He can take the hit.
No.
What? Huh. You,
I hate you.
I hate you.
You.
Where did you hide him?
You know what
Huh?
she did? She pushed me.
He,
Because of her age and her gender, I didn't allow myself to.
because he said he's the strongest, so I pushed him. So, like, to prove that I'm more strong than him.
Did you prove it?
Yeah, I pushed him.
Did he fall down?
Yeah, nearly.
Oh, but then you didn't prove it if he didn't fall down.
But
He needs to hit the ground.
But I
Did
mean,
he hit
he's
the ground?
scared.
Huh?
I mean, he's scared.
You're his what?
She made him
Scared.
scared.
Yeah.
Huh?
She's scared of him.
No. Yeah.
No.
Do question 1, please.
Hey.
If you look here, exemplar physics end of semester 1 test, A1.
Now write it.
Oh my goodness. It'll take 1 minute. Great. So what lesson is A1 from?
Momentum.
Mechanics.
What lesson? No, not momentum.
I never.
Equilibrium.
Do we have a lesson called equilibrium?
Well, that's what's called in high school.
True, equilibrium, it is true.
Uniform rod.
That's so not the name of a physics lesson. Today we will study uniform rods.
Principle of movement.
Yes, that's it. You are the wave.
Add.
Oh yeah. Thanks to FF.
No. Add.
Ah!
No,
Yes.
just write FF.
No. Add.
Okay.
No space. FAZ. Dot I Z. No. FAI. FAIZ. Dot PH. Yes.
The heck is
IG.
this? IG.
No.
IG before. IG with the
before.
picture.
IG before what?
The add.
IG, 2 dots.
2 dots?
Not I.
Like, no, as in like, one.
Colon?
Yeah.
What the heck is this?
My Instagram. My photography Instagram.
Fair enough.
I need all the credit.
And we can't forget Stephen's trademark vertical lines.
Very unique.
Physics.
Fizz. No, just fizz.
Fizz. Fizz? Fizz. Non-Fuang class.
Huh?
Experiment.
Very exciting because
You are the wave. Yeah.
Wow.
Maybe I need a Mason in here.
Can you do the experiment again?
No, because we
Can you
need
watch
2
it on YouTube?
speakers.
never have experience.
No, yours is
Twice.
correct, maybe not. For me,
Twice.
it's not something else.
Twice.
Twice.
Force transistors.
Are you finished A1, Yusuf?
No.
When I did experiment with those,
No. No.
why?
Like this?
Like, if I measure it properly.
They're not loud enough. They're just not loud enough. You could do it for the snail and ask it to stand where the interference is. You finished A1, Yusuf? Come on, chop chop.
Can I work them?
Yeah, but just turn it down a little bit.
You don't hear it.
Don't we have to change this to grand?
Guys, I'm so tired. I'm about to fall apart. Will you please just do the question?
So this is the force, and then perpendicular distance. Jesus.
I don't remember.
Which one?
Oh yeah.
A.
Y is equal.
Hmm?
Can't be equal.
Why can't it be equal? Maybe you made a mistake.
Yeah, it can't be.
Come on, Faisal, get working. Get working.
No.
Goodness, you should be nearly finished the first one now. Yusuf?
Yeah, for sure.
Okay, 1 more minute and then it's answer time.
Next exam you do is example of physics final or the 2014-2015?
14, 15. Right, can we have a look at A1 now? You finished it for him?
Yeah.
Great, good job. Let's have a look at A1, see if you got the right
I
answer.
think I did this one too.
Okay, let's see the question. A uniform
What's unicorn?
constant.
It's not unicorn.
You know
It is
what
not
it's called?
unicorn, no.
Unicorn.
It is not. And it's not this uniform either. A uniform plank of wood of 5.5 is supported by 2 beams. Okay, so the first one is at 0.2. And the second one is at 1. And then the last distance is 0.5. Now, what's the total length here? 1.7. So what's the middle of 1.7? 0.85. If that's 0.2, that's another 0.65. So it'd be like about here.
Oh, it's this one. The one you gave us in the ESAP.
Oh, you had that lesson. Great. Did you find it useful? Not really, no?
What we did was we...
But it's not this
which lesson is this question from? That's all. Was
That's
this
all?
the thing you prepared?
It had a bit more to it than just that.
Yeah.
Who delivered the class?
So
No, it was,
point-
we did a couple of things. First we
Yeah.
like, say the chapter and
Yeah, yeah, okay, yeah, yeah.
identify the lesson
Yeah.
and then see
Yeah, yeah,
where
yeah.
we're weak at
Yes,
and
yeah.
where we need to focus, whatever.
Good.
I did the version 2.
Okay.
And I have some questions and
Okay, we'll get to it. Now, what equation can we make first? We can say R plus S equals 5.5G. Are you okay with that? Yusuf? Is this okay? Yeah. Now, what equation should I make next? I should make a turning force. What turning point should I take? Huh?
Oh, no.
Here?
X.
no, take R.
0 point.
Here.
Take R.
The
Yeah.
half.
But we need to find the R because the question is.
We need to find S.
You need to find
Oh,
S.
wait.
Oh, first they want the one. First they want the or. Yeah. So Fong's right. We should start with S here. So is this clockwise or anti-clockwise? Clockwise or anti-clockwise? So this one should equal this one. So we can say if that's 0.65 and this is 0.35. So we can say 0.35 times 5.5G should equal should equal
18.
1 times or. Because the distance from here to here is 1. So look, I have the or already. What's the or here, please?
18.9.
What did you get for or?
45.
That's a different answer to what he got. 18.9.
Yeah. Yeah,
18.3.
18.339.
Okay, and then if we put that in here, we can get the S. S is 5.5G minus 18.9.
35.1.
35.1. How many marks for that?
4.
4.
Yeah.
Should only take you like 2 minutes to do.
I have a question.
Is it good?
I don't know.
Okay, go for it.
No, what's that 1R? I don't understand.
That's the clockwise turning force from here. The distance is 1 meter and the force is R. That should equal this distance, 0.35 times 5.5G. This turning force should equal that turning force at here. This is from the principle of moments lesson.
What I did was 1.7.
1.7. 1.7. What's 1.7?
Total distance.
Is it?
Yeah, 1.7, yeah.
1.7 divided by 2.
Mm-hmm.
Center.
Mm-hmm.
0.85.
Mm-hmm.
And then I subtracted 2.
Subtract the 2.
0.2, sorry.
Yes.
Go
And
on.
then I just multiplied the 0.65 times 5.5. Sorry,
You did?
0.5. 0.65 minus 0.5.
Yeah.
0.85.
You started off this explanation with I just, and it's getting quite long now. I've lost track of what you're doing. Did you pick a turning point?
Yeah.
What is your turning point, if
The
not this point S?
No, I picked that point
Yeah.
for the first part, and for the second part, I picked the other point. Okay, let's go on with the question.
It's,
Good.
it's,
You
al-
picked
it's
S
also
as the
okay.
turning point?
Yeah.
It's longer.
Yeah, okay, and then R times the distance between R and S. So 0.65 plus 0.35 times R.
That's fine actually, the way you did it. If you use S as a turning point and R as a turning point, you'll get two equations. One that has S in it and one that has R in it. And they both should give you the same answer as R and S. So if your answer does not match up, it means there's a small mistake somewhere. But the idea of using that point as a turning point and the other one as a turning point should work. So I can check in a moment where the mistake happened then. But to answer your question, in principle that should work. Yes? Okay, can we have a look at 2 please? What's 2 about?
Pendulum.
No. We haven't done that yet. But we have done trade.
Yeah, this is,
The
yeah.
first part only, right?
Nope, both parts.
The second
Or
one.
three parts.
Make,
Wait, the second one is not in.
No.
No, not for you. You don't have this in your semester one, so you're on to A3 now. Try A3, please. What's your question?
in semester 2, do we have mechanics?
No.
So we finished.
Oh my goodness. You see that guy there with the hat? Yeah. He has asked me that question you just asked me 3 times now.
But
He's asked me this 3 times and I answered it 3
But
times.
that's
She wants to know if there'll be mechanics in semester 2. Now please tell her the answer.
No.
but
Yeah.
Simple stuff.
No, I didn't say. I said it's a part of mechanics, but we're not doing it.
What's the part?
Gravitational and field strength.
I wouldn't class that as part of mechanics.
They said when we're doing this, they're like, this is mechanics because it has gravity and.
Who said that?
They said that.
Who's they?
No.
Key. Did I say that?
No, I'm telling you, that's why I mentioned mechanics.
Okay, well, maybe this was a mistake. We are not doing mechanics, electricity, or waves in semester 2. However, of course, when we do the chapters in semester 2, we may mention some things from these chapters. For example, remember when you did electricity? There was one question in it that had power in it about a car, and we required something from mechanics. Do you remember when we were doing the stationary waves? We had a question with the radio towers and the car travelling between the radio towers. Okay, so we're not doing mechanics in semester 2, but we may require something from mechanics as part of a question. You know what I'm saying? Oh, great. Now please try A3. And remember, don't believe anything he says. He says. He says.
but
He
he
says.
said he's a king. So
Him. Especially him.
so don't trust anyone.
And definitely not me.
So just you.
No, don't.
Don't.
Don't. There's only one person you can trust.
Me.
Yes. Now try number 3, please. Just do a question. Please. I've got the alarm going on outside. I don't need music on the inside. I have absolutely no free time today. I'm just trying to get through today. Do you want me to have a look at that one, Andrew, number 1? Or you're happy to keep going?
No.
Mr. Steven,
So unbelievable, but okay.
a circular saw rotates at 295 revolutions per minute. Did we do this?
Yes.
And then determine the angular velocity. We don't know the radius. We only know how many revolutions per minute.
Correct.
So what formula should I use?
No formula, common sense. It's 290 revolutions per minute. Each revolution is 2 pi radians. Therefore, there are 290 times 2 pi.
Each revolution is?
You know how much from maths class, how much a revolution is. How many radians in a revolution?
2 pi. 2 pi r? Just 2 pi. So 295 times
2 pi divided by 60 is the omega.
the angular
Yes.
velocity.
Yes.
Isn't that's not, is it radius over?
What's the formula for angular?
Oh, it's theta over time.
Yeah.
Okay.
So you've been given the theta and you've been given the time.
Mr. Steven, my question was, What's the relevance of this one?
That's the distance from here to here.
But, I mean, like, for example, okay, if I just did 1.7 divided by 2 to get the center,
Yes?
and then I just minus 0.5,
And that gives you the distance. So you just worked out that distance, but by why are you minus 0.5? I don't
for
know.
that,
You want this distance?
no, to the perpendicular distance for B, for S.
Distance from where to where? What distance are you trying to work out? From where to where? You know what I mean? A distance means 2 points, from a place to a place. What are your 2 points here?
From here to here.
Ah, so this distance,
Yeah.
fair enough. So, if you want this distance, oh, I understand now, you're getting this and you're minusing this to get this, okay.
Yeah.
And did you get 0.35 as well?
Yes.
Okay.
And then I just times it by the
5.5g?
weight, and I
Yeah.
get the answer.
No, you're not finished, you're only half finished. So what you've just done, okay, you took this point here, and you've worked out this turning force.
W?
But that equals this turning
Or
force.
what to get the...
No, because this is 0.2.
No,
Yeah,
you've just
no,
used this turning point, because you've used this distance. So you need to be using this distance. The distance must be all referenced to one common point.
Yeah.
So if you're using this point, which you should, and this distance here, which you should, then for the next part, you should be using this distance here with the or.
But I get the same answer.
What did you... Yeah, but you got the same answer for the wrong reason, because you're saying that this is equal to or, right? Is that what you're saying?
I'm just repeating the whole process again, which is 1.7 divided by 2
Yeah.
minus 0.2 this
Yes,
one,
yes, yes, I understand.
and then I'm timesing it as well.
Oh, wait, hang on, you're repeating the process,
You know this formula?
yeah.
Can you
Oh.
see it?
No, this is
So it's
this
the
is what
C.
you did.
Yeah.
I did this like without writing it down.
Oh, I don't like this. I don't like that you didn't write it down.
What?
The question?
And secondly, I find the way you're doing it somewhat confusing. You did this minus this, and you got this.
Question 3?
Yes. B.
And then you did,
And then I just did the whole thing again, but for the other side.
and you got a number.
I want like a
And that number is the answer.
Yeah.
And the only reason your method is working is because the distance from here to here is 1 meter. If I change this distance to 2 meters, then the number you would get at the end would not be the answer.
squared.
So you got the answer by coincidence, I'm afraid.
What is your
You need to be doing it the way I'm doing it. What?
What's your answer?
Wait.
I didn't get the answer.
Did my math make sense or not?
I have 45.
Okay, so this 1r is the distance from here to here.
Yes, that's why when you did it, it worked out because of the one there, the number you got, which was the same as this, was the or. But if the distance wasn't 1, then the number you'd have on your screen would not be or. It might be like 2 or, and you'd have to divide it by 2. So it just worked in this case.
No, it just worked.
What? I'm doing it now.
The acceleration you use F equals ma.
I'm doing it now.
You use the A from the
Tension.
angular,
What does that mean?
Force in string.
Oh, so it's the constant.
and the acceleration is angular velocity over.
Guys, can we do number 2 now? Or number 3? Wait, sorry, Yusuf, are you still working on it?
On the second part.
Okay. 1, are you still doing it? Yeah, okay.
How long does this alarm go?
I don't know. I'm tired, and I'm hungry, and I'm stressed, and I'm busy.
Wow.
If you need help during your private lessons, I can do them for you.
I've got too much to do.
Why don't you think of opening like making a website
We have,
where people can pay for online teaching classes?
we have.
I do online teaching. On Skype.
No, but like you just upload the lessons and then
I don't really think there's money in that, because there's plenty of free websites online that do stuff like that. Khan Academy, Coursera,
Oh, yeah.
Udacity.
Yeah, Khan Academy is nice.
So why would someone pay for something that's free? You know, this is
Do you
why
like-
websites like the Pirate Bay exist.
Do you like assessing stuff?
No, I just do the lesson on Skype. Sometimes actually people pay for me to record a lesson for them, so I'll make a lesson, record it, and send to them in YouTube, and then bill them. That's nice, because you can do that in your own time. Make the lesson, send it, and get paid. You finished it?
But like, I don't think that's the best way for the student, because it doesn't, for me, because I won't be getting any time to ask any questions.
Yeah, it works for some people and it doesn't work for others. Probably wouldn't work for you.
Yeah.
But what we could do is we could make the video for you and then get a cardboard cutout of a teacher, and then you can ask the question to the teacher, and the teacher could have some programmed answers.
Face on!
Yep, that's it, yeah. It would need to be something now, because a lot of the time your questions are like, couldn't I do it like this? So the teacher needs to say, that's okay, but I recommend doing it my way. Something like this, or what other response could I need? Maybe a couple of random, no, don't do it that way, do it my way. Yes. Might work,
Yeah.
as long as you don't ask any question that needs a direct answer. But you don't usually, so it's okay. Alright, number 3. Yusuf, have you got number 3 finished? Thank you. Wong?
Yes.
Wong, have you got it finished? Sorry, thank you. Wong. Number 3 here. An object of 2.5 kilograms is attached to the end of a string which is rotated in a circle of radius 0.5 with a constant speed of 3 meters per second. The radius is 0.5 and the mass is 2.5 kilograms. Part 1. What is the angular velocity? So remember we have the formula V equals omega r.
Yeah.
So omega equals V over r, which equals 3 over 0.5, which equals 6
Right.
radians per second.
Radian?
Yeah.
Yes?
Angular velocity.
What is the tension in the string? So this is being spun around. So the tension force is the force which is causing circular motion, which is equal to mv squared over r, which is equal to 2.5 3 squared over 0.5. So that's I can do this in my head. 45 newtons. 9 times.
Why you not use MI?
This is MA. But A, angular.
yeah.
Oh yeah, sorry. T equals F equals MA, which equals mv squared over r. The same thing. Right. Number 4, you can do.
No.
You should be able to do number 4. Number 4, please. Number 4. There's nothing to what? Number 1 is what's the difference between a scalar and a vector. Do you know what a scalar is?
Yeah.
Good. Do you know what a vector is? Good. Explain the difference. Write something for me. And don't say a scalar is a scalar and a vector is a vector. I won't take that.
Determine the potential difference across the combination after 3 time constants have elapsed. What formula is this?
I won't tell you. Because I believe it's in the formula book. But it is something we did in class. There's not many electricity formulas. Not like mechanics. You should be able to find it in the book.
It's to do with capacitors. Questions about capacitors.
Yes, this is true. The capacitor question is to do with capacitors. Correct. Scalar has magnitude and not has direction. It's good, but the grammar's bad. Vectors has magnitude and direction. Fix the grammar in scalar. Has magnitude and
Hasn't.
has magnitude and hasn't direction. No, you can do better than that. Has magnitude and
no direction.
That's better, actually. But what verb could you use here if you wanted to use a verb? And I know you want to use a verb. Yes, you do. Has magnitude and does not have direction.
That's not
Yeah. But no direction's fine. No direction's fine.
Is that the right angle?
No.
nice. First time I can do
Well, you must find it fine.
definition.
Congratulations.
Direction of the result.
Wait
This
till Turbo hears about this.
I don't know.
Yes, you do. Add these two vectors together. They're two vectors. Add them.
So 110.
But
Oh.
it's
You take that
different
from
than result. Like,
Yeah.
what that's called?
Resolve.
Yeah.
Yeah, resolve and add.
Yeah.
You can do
No,
this.
it's different.
Yeah,
It's
you
not.
have two
Like,
angles and the side between
this.
two
No,
sides
look.
between them.
Resolve
You
this
can
one
find the area.
and add it to this one.
Not sure if you can find it.
Area.
Are you doing number 4, Yahi?
Yes.
Second part.
Second part, good. Wong,
Second part.
good.
What you can do is you can resolve.
How? Yes. Resolve. Everybody's talking about resolving. No, not like this. Not
Yeah.
like this.
Yeah, I realize. Because they want the direction, so they want the angle.
Resolve.
Yeah.
No, goodness no. Not even close.
Mr. Steven, is it W equals half?
No. I forgot what the question was, Faisal. What did they want to know?
Potential difference across combination of three capacitors after three time constants have elapsed. Is it half CV squared? No, it's not. There is
Firstly, you must have a formula that has time in it.
there
Otherwise,
isn't any formula in here.
but then you have your answer. It's a formula we've done in class, it's not in the book.
Okay, then can you give it to me? That's why I asked for it.
Yes, I can give it to you. Simply open up the notes you should be taking like a good student and go to the lesson you should have been in. You probably were in it. I don't think you've missed any lessons, have you?
But he's not
I'm not your
writing
secretary. Go open up your own notebook and get the notes out. I don't think I would look very good in a dress, okay? I'm not your secretary.
this.
No, don't skip it. You can do it. Resolve it.
But I don't know
Resolve
vector.
it.
I don't know vector.
You do know vectors. Resolve
No,
it.
I
This
don't
direction?
have that lesson.
And this direction. You have this lesson. You've done it twice.
No. No.
Well, you watched the video.
I watched the video, but I still can't understand.
Okay. Has anybody finished number 4 yet? Andrew, how's it going? Have you done 4?
Could you give us the formula to find the
I'm
area?
sorry, did you not hear my conversation with Faisal there? And you thought, he never said he's not my secretary. What do you want? You want something that you can easily get on Google, right?
No.
What do you want?
It's
The formula for the area of...
Not the area, to find the side of the triangle, not the right angle triangle.
What are you talking about? The hypotenuse?
Yeah.
No, it's not the hypotenuse, it's not the right
It
angle.
is the right.
It's not
It's
the
not
right.
the right angle triangle.
So it's not
but
the
the wrong
hypotenuse.
side.
Yeah.
You have the sine rule and the cosine rule from math class that you might find helpful
Sine
in
rule.
non-right angle triangle situations.
Sine rule doesn't. He has two sides and the angle between them.
Then that leaves it to be the cos rule. Did you draw a parallelogram for part 2 of 4? Is that what you're doing?
No, I drew a triangle.
Fine, yeah, triangle's fine, yeah. Yusuf, you drew a parallelogram?
60.
Interesting, we're all doing it different ways, but they all should give us the right answer.
Cosine rule, yeah.
Right, I'll do it now. I'm doing it now.
This square.
Yeah.
I want to skip electricity.
Listen, everybody. This isn't even electricity, this is vectors.
No. the question 5 and it's just
Okay, fine. 4. Can we all look up, please? Part 1. What's the difference between a scalar and a vector, Wong? Wong.
Huh?
What's the difference between scalar and vector?
Scalar has magnitude, and
Yeah.
vector has both magnitude and error.
Great. Now, you
no,
Yeah.
that's it. He only
say again. What's a scalar?
Has magnitude only.
He said
No,
only.
not only.
Well, did you say only first time?
No.
Yeah, I did.
No, you can check the video.
Yeah, there he is. We were.
No, you not.
If you listen to the video and it turns out he didn't, like the video and post the time when he said it, and I will give you a prize for Turbo.
Yeah.
What if I did this?
For Turbo.
Oh, what is the...
Now,
What if I do?
yeah, she's right. You really need to stress that it has only magnitude and not direction. Yeah. Okay, because both of them do have magnitude. The difference is one has direction and one does not. That's the difference. Okay, now Yusuf, Yahi, and Fuang all are looking at part B differently, but you should all get the same answer. So, Yusuf, you went with a parallelogram. Yahi, you went with a triangle. And you went with trying to resolve them.
No.
So I will do it by using a triangle and by resolving. So how big is this vector here?
66.
60 newtons. And how big is this vector? 30 newtons. I know it's not the scale. And the angle here?
70.
70. So if you draw that over here to make a triangle of the same angle, then the answer will be this vector. Because you're using the triangle rule here that we did in class. So we need to know this angle and this length. So since we have this angle, we can get this length by using the cosine rule. L squared equals 60 squared plus 30 squared minus twice 30, 60, cos 70. So what do we get for L, please? Or does someone have it already?
57.
Are you sure? 57.2.
2.
Is this what you got?
1.7.
Okay. And now we need to get the angle. How can we get the angle here? I think a sine rule will do. So if we call this angle theta, we can say sine theta over 30 equals sine 70 over...
But why not use
50.
180?
We only have one angle.
But this is 90, right?
No, it's not.
No?
No. Is that right? Yeah, 30 times sine 70 divided by 57.17 sine inverse, and the theta here is 29.5 degrees. Now that's not the way I would do it. The way I would do it is by resolving this vector into a vertical and a horizontal.
Yes, I did this.
Yeah, so this side is 30 cos 70. And this one here is 30 sine 70. So your final answer will be a vector this way, where this side is 30 sine 70, but this side here is 60 minus 30 cos 70, because it's being pulled the other way on the left. So what is 60 minus 30 cos 70? No, this side though.
Yeah. 49.74.
And then this one here is
28.2.
28.2, okay. So how do we get this side? Our buddy Pythagoras.
And then use the SOHCAHTOA and turn this.
It's the same answer. And then the theta is tan inverse 49.74 over 28.2. And you get the same answer, 29.5. That's how I would do it. Although technically speaking, I suppose the left method matches up more with what is in the class and the syllabus. However, what I don't like about the left method is you need the sine rule and the cosine rule, which to me seems needlessly complicated. I much prefer the method on the right.
Don't we need the tan rule?
Yeah, just over this.
Oh, it's tan.
Tan
it's
inverse
SOHCAH.
Yeah.
It's,
Because he made a right angle.
I want a T-shirt that says that. It's TOA. Yeah. Okay.
Why is the vertical
Just to
vector 60 minus 50%?
You mean the horizontal?
The horizontal, yeah.
Yeah, because there's a 60 to the left and a 30 cos 70 to the 60 to the right and 30 cos 70 to the left. So the 30 cos 70 subtracts from the 60 because the force is pulling it in the opposite direction. So it combines by subtracting instead of adding. Does it make sense?
Yes.
Yeah. Okay, let's see what's next now. We've got a very nice electricity question in number 5. That should be a reasonable 6 marks there. Give that one a go, please. Number 5. Question, please.
I didn't find the formula, but I want to ask again.
No, since you failed to find the formula in your notes, I will tell you the
I
formula.
have the formula written down in my notes, but I still can't see the formula.
Okay, what's the formula?
I equals I0E for 1 over 2 T.
Now, do
This
you
is the
know the
formula.
current?
Yes, I found it.
You know the I and the I0?
I know the I.
So what are you giving in the question?
We have the capacitance, we have the voltage, we have the coulombs.
Yeah.
Yeah.
And do you know the Coulomb charge after the time has passed? Or,
Determine the potential difference across the capacitors
Yeah.
after 3 time constants have elapsed.
so you need the formula. You have I equals I0, but there's another formula. Do you have it written down with it?
Which one? Because I have lots.
Let's see.
No, before.
You see what your problem is here? You didn't write down all the formulas from the lesson. There are 2 more formulas which you do not have here.
Which ones are they?
And we do have them. And you know the funny thing is, I wrote it down for you.
Oh. Okay, so I use. Yeah, okay, I use this, and that's it.
So the reason I wrote that in your book was because during that lesson you must have asked how to do something, and I must have had to write it down because you didn't write it down from the board. You see the importance of notes, and the circle of learning is complete. How are we doing with 5 over there, Andrew? Are you doing it, the electricity one?
Yes,
But we still don't have the time. Or is it 3 times the time?
3 times the times constant, yes.
Is the T?
It just said, didn't it say in the question?
Yeah.
3 time constants.
Yes.
So if you replace the small t with 3 time constants in the formula, look at the formula, what happens to the time constants?
One of them will cancel out.
Yeah, so you're only left with
2.
3.
After 3 time constants.
You're left with 3.
Small t is
3
3
time
t.
constants. Yeah, 3 time constants.
3 tau. I know.
3 tau.
Tau. Over tau.
Tau leaves you with 3 because the tau is cancelled. Dum, dum.
Yes, okay.
Yes, alright, still with me? And do you know the V0, the voltage at the beginning?
50. Yes.
So the answer is 50e to the minus 3. No, not okay. Really not okay.
Can we use the loop and
Yes.
numbers? No?
What's that? You want to use Kirchhoff?
Yeah. I want to learn.
Interesting.
But can I use?
Yes, I encourage Kirchhoff.
But this only like.
What do they want first? The resistance.
No, I have that.
Good. What do they want second? The current.
So it's like, I want.
Yeah, but did you add these together and this together? What's the total resistance? This is it? Is this
Yeah.
this and this?
Yeah.
Yeah. So you have 8, and then one resistor is this. So you have OR, and you have V, and you want I.
Yeah.
So you can use VI OR triangle. VI OR.
Yeah, I know, but like V, like V
This is
here,
V.
same like V in here. Like.
No, it's not.
Very,
No, what you're doing
very,
is you're changing this into this. The V is not the same. Here, 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 here. The V here and here are different, but you don't care because the current is the same. The I is the same. Yeah. So the V that you get for the 8 will be for the I here. But that is okay because that's the I that they want. If you use a V here, if you use this V, then you get the I here. But you don't want that I, you want this I.
I use equal, I equals to BR to find I0 if I have B0.
Yes, you can use VI or triangle.
To find I0.
If you know V0 and OR, then yes.
R doesn't change.
Technically speaking, it changes, but for these circuit diagrams, we consider it to be constant. But just in a technical sense, OR changes slightly. But we imagine these resistors as being of constant resistance. As you probably know, usually when resistors heat up, change. Yusuf, how's number 5 going? Are we nearly finished?
I is potential difference? No.
No,
I is V.
the voltage is potential
Yeah,
difference.
so it says this.
Will we do it now? Yeah. Yes. Is it on the syllabus? Let me see. What am I doing? How do I? Oh, here we go. 8? No. 9? No. 10? No. 11? Yes. 12? Yes. B1? Yes. B2? Yes. B3? Yes. Right, can we do A5 now? Yusuf, what is this cell voltage here? 8. And then this resistor?
0.5.
And then you have a triple resistor set here, do you?
Yes.
12, 3 and 2. And we want to add everything up. 1 over 2 plus 1 over 3 plus 1 over 12. Let me see, that's 6 over 12 plus 4 over 12 plus 1 over 12. It's 11 over 12, which then becomes 12 over 11 plus 0.5. So 12 over 11 plus 5.5 over 11, that's half of 11. That's 17.5 over 11, which is 35 over 22. Is that what you got for the total resistance? Yes, excuse me, I do not have a calculator. Right, that is part A. Thank you, what am I saying? Part B is what's the current, is it?
Yeah.
So using VI OR, I is V over OR, which is 8 over 35 over 22. 8 times 20, 8 times 100, 176 over 35, is it?
Wow.
I got
Nice.
my,
It's right. It's right.
I don't know what that
Question.
It's right.
Okay. And part C, what do they want?
Is it 5?
Yeah, yes.
I didn't, is
Five.
this 5?
Yes.
Okay, I believe you.
So, yeah, if maybe you used a different value for the resistance.
Yes.
How can 176 divide 35?
No, it shouldn't be 5, yeah. What are those?
It can't be fun.
Yeah, it's 35.2. This is right.
Yes, but like I used for the first time I did it, I used
Why is
0.5
it
for the
5 points?
But the voltage through 0.5 is not 8.
Oh,
So what I did was I used the total resistance and the total voltage to get the total current. If you do what you did, it will work. However, you will first need to work out the voltage through the 0.5 before you can get the current through the 0.5. You've just made more work that way. Your answer will work if you do it that way, but you have more to do first. Okay, what do they want in C? Yes.
Why is it 5.5 over 11?
That's 0.5. 0.5 is the same thing as 5.5 over 11. I just changed it into a form so I could add, because I didn't have a calculator. No,
it's right, it's right.
I don't have a calculator, so I'm doing some manipulation so I can add it together in my head. I changed 0.5 into 5.5 over, yeah,
It's like half of 11.
yeah. So I could add it to 12 over 11 so I could get this. No, you're thinking, how did I get this? This is my brain, okay? I just did this plus this to get this. I know.
Is Steven, 35 divided by 22.
Forget about this. This is just me not using a calculator. Using a maths trick to add it in my head. Yes.
35 divided by 22 is 1.6.
Okay, that's what you said.
Yeah.
Yeah.
Now 8 divided by 1.6
It's fine.
is 5.
Yeah.
8.
Divided by 1.6.
But it's
We're talking
1.5.
about the current.
Hang on. We want the I, which is V over R,
Yeah.
which is 8 over 35 over 22. Now what's 8 times 22? Is it 176?
Yes.
Over 53, which is...
Yeah, so 176 over 5 is 35 point...
No.
Oh, sorry. 176 over 35 is 5.02. What answer did you get?
5. But
Because
someone said
you-
35.5.
No, that was me misspeaking, I'm so sorry. This answer is right. And what answer did you get?
5.
Exactly 5.
Yeah.
No, you
Because
missed-
you changed the 35 over...
Yes, because
Yeah.
he rounded the 35 over 22. It's probably not exactly 1.6. What is it on the calculator?
7.5906.
Because of this rounding, your answer comes out as exactly 5, whereas my answer is actually 5.02. Yeah.
But like,
That's fine for the
Yeah,
exam.
something
Well,
like that.
no, what was it, 1.59 or something?
1.5900.
No,
Rounded to 1.59.
yes,
That's
not 1.6. You need to be 1.59. Yes. 1.6. If you round to 1.6, you might lose a mark. You're looking at 1.59 thinking, why can't I use 1.6? Don't. Use 1.59. Yes?
So always break the sum up?
no, I'm looking at 5.02.
Well, really 4 is best. What?
I'm looking at 5.02. Difference of 0.02.
And if somebody's life depended on your calculations, that's an important difference. What is part C?
Power and the 2 ohm resistor.
Right, power in the 2 ohm resistor. So, what's the formula for power? IB. Now, do we know the V going through the 2 ohm resistor? No. So we should replace the V. If we use our VIR triangle, what's the same thing as V? IR. So this can be rewritten as I squared or. Do we know the I? No, we don't know the I, because the current gets split 3 ways here. So either way, we're going to need to calculate the I and the V. So we need to decide. We can either get the I or we can either get the V.
Don't we have the I from...
No,
the different one?
that's the I here. Yeah, that's the I here, but it gets split 3 ways here. Now I'm thinking the V will be easier to get than the I, because if I can get the V here, and I know the total V must be 8, I can take it away to get the V here. And because they're in parallel, the voltage is the same throughout. So let's start by getting the voltage here. What's the formula for V? I or. Do I know the I?
Yeah.
Yes. And do I know the or? Yeah. So the V here is 176 over 35 times a half, which is 176 over 70.
2.51, but don't trust my answer.
2.6.
2.5.
Okay. Now, next, I need a formula here for power that does not have the I in it. So what can I replace I with? V over R. So I can rewrite this formula as
B squared over 1.
V squared over R. Now, do I know the R? Yes. Do I know the V? Nearly. The V would be 8 minus 176 over 70.
5.09.
Yeah, well, I've reached my maths limit now. So this final answer is
15. Just 15.
that last part is a little tricky because we were forced to calculate either I or V in the 2 ohm resistor. Trust me when I say it, I'm doing the quickest, shortest way I can think of. If you wanted to find the I, you might have to use some kind of Kirchhoff rule. Yeah.
V squared over R.
Yeah, it's another formula for power. What's wrong? Okay, what's the next? Yeah? What?
8 minus.
Yeah. 8 minus this voltage. This one here.
Why?
Yeah, well I have to calculate the voltage there. So
The voltage is like the voltage 2.
no, the resistance is 2.
Yeah.
Hmm.
So it needs to be like the V also.
I need the voltage here. Correct.
2.
No, the voltage here isn't 2. The resistance is 2. The OR is 2 here.
Oh, so not this one. This
They said the 2, didn't they?
Yeah.
Yeah.
I thought the 2 is needed like 1, 2, 3, 4.
Give me this phone. Let's see. You're crazy. Crazy person.
That's 5 ohms. 2 ohms.
Determine the power consumed in the 2 ohm resistor. 2 ohm. You see that? You thought this said the second resistor.
Yeah.
Yeah. Okay. What's the next question? 6. You can do 6. 6, please. Try 6. Can I scroll down, Andrew?
Yeah.
Yep. Which picture to pick? I do kind of like. I do kind of like this one because it is a little bit like obey me.
7, 8, 9, we don't do.
Yeah, I think Lee was asking me that. Nice. Nice.
They not say anything about like parallel after
About what?
parallel after.
No, they do not say anything about power. They only talk about voltage and resistance. This is the lesson on EMF and internal resistance. You know it? Good. I'm glad you know it. It's on the exam. By looking at all that page turning through your notes, I have a feeling that 6 is a difficult one. So shall I just do 6 now, or what?
No, not that.
No!
No.
You're going to do it?
Yeah.
Unbelievable. I do not believe this. Nobody believes that. Does anyone believe that? No. I know it's just that. Yeah. Yahi, do you have number 6 there?
I have 1 and I'm working on 3.
Alright, okay. So it's just Yusuf that's having trouble with it.
And Andrew.
And Andrew, okay. What's that? You did it?
No.
Yeah, you didn't.
Wait.
This is the V in, V out thing.
No, that's the potential divider lesson. This is the EMF and internal resistance lesson.
What does EMF stand for?
Electromotive force,
What's the definition?
or easily murdering Faisal.
So funny, I can't.
You can't contain yourself. What?
On Google. I tried looking it up and
Okay. You know, a lot of Google search results are based off your history. FYI.
Oh!
It's the rock band.
Oh.
Epson Mad Funkers.
Indeed. All right. Okay, I'm gonna do 6 now. It looks like you're hitting a bit of.
Which makes sense because I looked up Epsom salt the other day.
It does make sense. Google is smart. Dear Mr. Google, why are you so smart? Okay.
No.
Yusuf?
Yeah, I'm stuck.
Right, I'm doing it now. Go on.
No.
I feel like I'm halfway.
Okay.
We halfway there.
Is that Bon Jovi? So no singing forbidden songs in class, thank you.
Forbidden? What?
What's forbidden? What's her name? Jessica something. It's Friday?
Jesus.
No. You know what I'm talking about.
Rebecca Black.
That's the
Right,
one!
yeah.
That is the forbidden song.
Friday.
That's the one. Talk about garbage. Okay. 6. Yahi, can you read out the question there? Go ahead for it.
A high resistance voltmeter is connected directly across the terminals of the cell, and the potential difference is measured as 3.5 volts. A 6 ohm resistor is then also connected across this
Okay, so just before you go, sorry. At the very beginning, what did you say the voltage was?
3.5.
3.5 volts at the very beginning when you measure it. Okay, and then there's a second half to the story where, let me just draw it again, you have your cell, but this time it's connected up to a some kind of a resistor. How big did you say, sorry? 6 ohm resistor, okay, and then what's the voltage now?
2.4. It falls to 3.4 volts.
2.4 volts now instead of the original 3.5. So if we look at this and use a loop here, there isn't really much of a loop because it's just E. So we'll use Kirchhoff's loop rule. We start with E, and then we go around the loop, and we're back at the OR. So it's E minus, and I should actually write in what the I is. So it's E minus I OR equals 0. But we actually know what, we actually know what the voltage is here. It's 3.5. Yeah? So we get E equals 3.5, yeah. So we have 3.5 at the beginning anyways. Now, when we look here, and we use our loop, we start at E, and then what happens when we get here? Minus, or plus, minus what? 6I. Yeah? And then we go back here. Minus I or, yeah, equals 0. But it looks like how many unknowns are here? 3. However, we know one of them. We know the E. So this is 3.5 minus, and let's take out this I here. 6 plus OR. I know, actually, they're probably looking for OR, is it? Yeah, I'd say so. Okay, so now how many unknowns do we have? 2. But we haven't made use of this 2.4 yet. So we know the voltage here is 2.4. Using our VI OR triangle, what does I equal? V over OR. Do we know the V? And do we know the OR? Yeah. So now we get 3.5 minus 6, 2.4 over 6 minus 2.4 over 6 OR equals 0. I hope I did that right. Yeah, I did. So cancel, cancel. 3.5 minus 2.4 is 1.1 minus 2.4 over 6 OR equals 0. So then OR equals 6.6 over 2.4. What's that? 3.3 over 2.1. That is 1 point something. I've run out of brain power.
6.6 over 2.4
Yeah.
is 2.75.
2.75, thank you. So I got a cram there, 2.75. Was the question asking you for E and OR?
Yes, second.
It was asking us for A, which is 3.5, and then there's a second part. Explain why the terminal potential difference falls when the
Oh wait, didn't I ask you for OR? I just
It
did.
is in
Okay,
a
good.
second.
And there's another part, ask me why does the voltage fall?
Yeah.
Why does the voltage decrease when you change the circuit the way you changed it? What's the reason for the I know, it's pretty obvious. Resistors use up voltages. Resistors, by definition, consume voltage. They consume joules per coulomb. So by increasing the resistance, you're getting more of a drop in the voltage.
So, do you just write that the resistance?
You could say you've increased the resistance in the circuit, and so more voltage is consumed. Yeah.
It's 3.3 over 1.
Yeah, okay, whatever. It's still 2.75. Thank you. Okay, what's the next one now? Can I see? Let's have a look. We've done 6.
No. What about this?
I've done all of it.
No.
I've done all of it. This is the answer for part 1. This is the answer for part 3. And the answer for part 2, we said because, total, or increased. 7, you should be able to do 7 for sure. And also 11 and 12.
Even
Yes.
like the 2 point
For what?
is
6?
Yeah.
What are you talking about? I've done part 1, part 2.
So you write this and you got 2 marks.
Oh, your question is, what's the deal with 2 marks for this? Yeah, maybe I should write a few more words in my sentence, but you get the idea. Do I even have a verb in there? I should have a verb in there, shouldn't I? Because total resistance has increased.
The total is increased.
But
It is because, yes, okay. Huh?
It's not asking you to explain, like, should you write a paragraph?
2 sentences for 2 marks. Yeah. What's the next one? The next one's a mechanics one, isn't it? 7, please. What are you looking at? The video I uploaded? Oh, I've seen this before.
The guy works on then he sees it and then he goes back.
How about you do some physics?
What?
Do some physics, please.
We have a
So, you want to know the verb towing? Towing the trailer. Towing is a verb. It means pull. Pull only. This one pull. And then trailer is what you have behind your car when you want to move things. You put them in this and you connect it to your car. It's like a big box behind your car. You put many things in it when you want to take many things somewhere. You understand? Box with wheels.
What about lorry?
That is another word for truck. Yes. Wheels. There we go. And then behind it, yes. Smaller. Okay, fine. Yes. Oh, beautiful.
So
No, it needs wheels.
How can you
Why?
share front page?
Because how could it pull it if it has no
How can
wheels?
you share front page here?
Faisal! Do your physics, please.
Is the not all is the trailer connected to the lorry?
It'd be a pretty sad story if it wasn't. Because the
Yeah,
trailer
but
would just
then-
sit there.
But then, like, the weight of the lorry doesn't include the weight of the trailer.
We have to be very careful with the grammar and the English here. If I just said weight of the lorry, I wouldn't naturally expect that to include the trailer, but it depends on the rest of the sentence, you know, so what does it say exactly?
It gives two ways.
Well, then you have your answer.
A lorry of mass is towing a trailer of mass.
I think that's pretty clear.
The first M is the lorry. And the second M? Oh, yeah, they do it now.
And where's the force?
This is
What force was it?
tension between.
No, the second force is tension.
What do you know is force?
The first part is probably the driving force, is it?
Magnitude of the force.
That's F equals ma. Do you know the A?
Yeah, we know the A, I know the A, but...
And do you know the M?
You add
What's the
The total mass.
drag is also this way, but friction is because of the ground. So, yeah.
Do you know what song, classic old song was in my head this morning? I'm sure you know it. You know, Don't Stop Me Now? No. YouTube.
Don't trust me now?
Don't Stop Me Now.
I can find it.
You think you know it?
Pretty sure I